it's a real pleasure for me to be able to not only just revisit the region and to be able to spend some time with you, but also to perhaps give you a little bit of context behind SAP and what it's doing around big data. Now, the topic in itself will probably cover a wide spectrum of different topics, but what I want to try to make sure that we do is to give you some practical value from this session as well. And to give you a real practical value add here, we've actually got a co-speaker here that will be joining me a little later on, Professor Krause here, who's going to be coming up here and giving us some real specific insights around how big data can be used in a meaningful way to be able to try and prevent medicine, and if you like, the cure of medicine to come about much quicker, so that we can hopefully get cures out there much, much quicker, particularly when we start dealing with pandemics like Ebola. So with no further ado, let me get going on my talk. And the first thing I want to just try to highlight is that if we look at technology and the value add of technology, for as long as we can remember, technology has really been used for three key value adds. Number one, it's used to draw down and, of course, eliminate the overall cost of your data centers and, of course, of your overall solutions that you bring out. The second thing it's done is it's allowed us to become much more competitive in the market that we lead in. Because the reality is that if we look at technology today, not only is it being used to be able to control costs, but it's also being used to be able to provide much more competitive differentiation. The reality is, though, the thing around us that's changing, right, is the fact that we're seeing much, much more technology taking on lives, in our own lives, okay, right, in a sense, that we see now that atoms are now beginning to turn into bits. And you look at that on the bottom here, you see all of these pictures that are floating by, and the reality is that this is almost nostalgic. You take a look at the record player, whether it's the camera or whether it's a telephone, each and every one of these physical things that we used to have in our lives is essentially being replaced now by something which is much more digital. So things turning into atoms are now becoming bits. And the reality is that these atoms turning into bits is great, but the opportunity that it represents is if you understand technology and you're able to use technology in a meaningful way, that you can, of course, gain that competitive value. The other challenging thing, of course, is now that what we're seeing in the market around us is that there's a new emerging set of new business models that are coming about. And once again, if you look at the bottom of the screen here, you see Uber and Airbnb and Nest. These are new business models that have come about literally from nowhere, disrupting the market, disrupting established businesses, but without actually any physical attributes or essentially any physical artifacts being owned by these companies. Think of this, for example, just looking at Uber. Uber is a company that's come about and is disrupting the entire taxi population of the world. Just as in London, for example, you'd have to go through a three-year knowledge acquisition base to be able to have the right skills to be able to get behind the wheel of a car and service the needs of the consumers. Now with Uber and technology, they don't own any physical assets, they don't physically own any cars, but yet through an application and the enrollment of businesses and the enrollment of drivers, you essentially have a complete network that's formed. Similarly, if you take a look at Airbnb, this is another prime example of a company that doesn't own any physical properties. It's not like the Hilton Group or Marriott or any of these other large chains. They physically don't own anything. They don't own any premises. But what you're able to do is just take a bed to somebody's house who's advertised it for a location, so to speak, and you're actually able to walk in there and take accommodation in their home. So you can actually advertise, self-advertise any particular accommodation that you may have. So these are all now changing and disrupting the world around us. The third attribute really is that if we look at these changes that are going on in the market around us, the reality is that there are certain trends that are going to shape our future. So you have mobility, you have cloud, big data, and the Internet of Things. And each and every one of these trends ultimately will shape our future. And I come back to those opening comments. Technology can be a competitive differentiator. Technology can help you choose, of course, how you use technology in a meaningful way to reduce costs, but it can also be used to innovate. And this is going to become a primary objective. The companies that are going to stay ahead and use big data in a meaningful way and are going to truly be able to innovate, that's going to be able to fuel the opportunities of the future. So understanding that the power of disruption is there with technology, the area that I want to spend a little bit of time on is to just take a look at some of these trends that are shaping our industry and shaping our environments around us. And if I start here from left to right, mobility is almost a given now. If we take a look at all of the leading surveys that are in the market today, I mean, you read between 96 and 98% of CIOs are looking at mobility as a defined channel now of communication. In many established markets and a number of new emerging markets, there's almost displacing the technology of yesteryear. The desktop is being eliminated and the mobile communication platform becomes a definitive platform. And in fact, I read a study recently that by the year 2020, there will be approximately 4 hotspots for every single citizen on the planet. So imagine that, for 7+ billion population, there's going to be 4 times that number of hotspots for us all to be able to communicate with. If we take a look at the cloud computing space, the one factor that I'll talk about is that there's massive investment going on in the data centers technologies around us. So there's huge investments going on. To share one statistic with you, in Q2 of 2014, so essentially 1 year ago, Google was spending approximately $2.35 billion a year, or in that quarter rather, on the data center related expenses. So think about that. That's fitting out their data centers to be able to provide scale for big data. Now, if you look at that number, 2.35 billion in Q2 of 2014, that eclipses what Google spent in the entire calendar year of 2008. So in the short version of that is that what they're spending in a quarter now is what they used to spend in the entire calendar year. So there's big investments going on in the data center. But by definition, you're still seeing that there's a huge fragmentation of these cloud offerings. If you take a look at the SaaS offerings today, you can see HR in the cloud, you can see CRM in the cloud, you can see all of these disparate solutions in the cloud. But the reality is that they're all disconnected. And we create confusion for ourselves at some point in time, having to try and integrate all of these cloud solutions back together again. So we need to be mindful about that. If we take a look at the big data space, what we're seeing here is this massive investment in big data platforms. And there's a variety of platforms that are out there. Some of these have been driven by the traditional vendors. So if you're an Oracle or Microsoft or an SAP, we have technologies that have been in the market for quite a number of years. And the reality is that in addition to these traditional platforms, there's also this huge emerging space around open source that's also occupying a lot of the big data technologies as well. So you hear of Hadoop, you hear of Spark, you hear of all of these different newfangled projects that have come about that are there to support big data. Now in this region, which I visit quite regularly, it doesn't necessarily strike me as a region that's actually embracing Hadoop right now. But I can tell you that the value of Hadoop and what it means for big data processing is going to become that much more important as we fast forward maybe 2 to 3 years out. If you're not familiar with the Hadoop construct, let me share with a little bit of insight in terms of what the genesis of Hadoop was, where it came from, and why it's so relevant to big data processing. So the fact is that if you take a look at Google today, Google is probably iconic because it's representing almost the World Wide Web. It's the internet. We almost think of Google being the internet and the internet being Google. But if you look at Google as a platform, Google, when it first was introduced, it didn't have the amount of content that it has today. So over time, they had to grow the mechanism, the platform, the framework to be able to manage essentially hundreds and hundreds of petabytes worth of data. So what the guys at Google did is that they worked internally to try and come up with a foundation, a platform that will allow them to have scale at being able to manage the worldwide internet. And here's just what one challenging problem that Google has to deal with. For every single website, for every single link that you have on a page as you traverse these pages on these websites, you have to, of course, have an index mechanism. You have to be able to say, if I'm searching for particular goods in Dubai, which happen to be serviced by a particular provider or supplier, by me just typing in a few keywords into Google, I expect to be able to find that information on the web. So what Google does is they actually have a web sprider, a crawler, that goes around and it looks at every single website, every new website that's ever been added or will be added, and they traverse. They go to the home page, and then they look down to through the hierarchies that will be available as but one example in all of these websites. And that's, of course, just the structured content, the web content. Imagine that you've got all this geospatial data now. You've got the location-based services data. You've got a whole variety of new sensory-based data that's being created. And Google somehow had to manage all of that information. So the way that they got around this was they invested in 2 core elements of the platform. One was called the Google File System, which effectively gave them the commoditized infrastructure of today, which is blades within data centers, all with their own little attached storage, and each blade in its own right becomes a de facto, almost a computing platform in its own right. So if you have, say, a terabyte worth of data or a petabyte worth of data, and you store it across, say, 10,000 machines, and you take a subset of that terabyte or petabyte worth of data, and you distribute it across a 10,000 machine cluster, what it means is that each and every single machine is only operating on a subset of the data. So think of the parallelism that you can achieve. And that's really the concept that goes through Google's architecture. It's using inherent parallelism within a highly distributed scaled architecture. So that's what the Google file system actually introduced. Now, of course, storing it is one challenge, but you need to process that data. And the other massive investment that Google made was in programming languages. And this is exactly where they introduced the concept of mapping and reducing, or the map and reduce programming language. And what that gives you is a construct where if you look at these 10,000 computers now, with all a subset of this petabyte worth of data, you can run a command or a set of commands on an individual node or individual clustered node, and you can have orders of magnitude of performance because you're almost essentially parallelizing the workload across tens of thousands of computers. So the headline really is here that Google had to manage the World Wide Web. And as a construct, they developed a platform that allowed them to have almost distributed scale inherently and a programming language that allowed them to be able to use that scale in a meaningful way. And that's fundamentally where Hadoop essentially came from. What happened is that Google, because they're good corporate citizens, they voluntarily gave up 2 white papers to the market. One was called the GFS, the Google File System, and the second white paper was called Map and Reduce. These 2 white papers ultimately became the Hadoop distributed file system and Map and Reduce as a programming language. And the Apache open source project inherited these 2 white papers, productized what Google had created. And now, of course, we have an entire industry that's been created. I gave you a little bit of detail there just to emphasize a couple of points. What's good enough for Google, of course, should be good enough for the rest of the industry to be able to deal with that massive scale of data. But what's happened over time is the platform is important. As I said, there's a massive proliferation of platforms, but all of the individual tooling that goes around the platform has not necessarily been invested in. So you think of it this way, you have ingestion of big data, you need to store it, you need to process it, and then ultimately you want to be able to visualize it. So think about that as the end-to-end value chain of big data. Ingest, store, process, and visualize. And we're seeing investments in areas of, say, ingestion or storage or processing. But you don't tend to have this thing happening end-to-end. And no single vendor has come forward with an end-to-end capability until SAP. And I'll describe what SAP's offering is in just a few moments. Now, the final trend I want to quickly comment on is a notion of the Internet of Things. Now, as far as the Internet of Things is concerned, consider that to be the best use case of big data. With all of the massive proliferation of data that's been going on around us, the internet started off with the internet essentially of content, internet of people. Now, of course, we have the internet of everything. And the Internet of Things ultimately opens up the arteries, if you like, of productivity and innovation, because we can start now building upon all of these different use cases of big data, but have a useful, meaningful exploit. So in terms of some examples of customers, now if you look at this transformation leveraging big data, here's 3 examples. One is molecular health. This is a company that has actually started using the notion of precision medicine. Now think of a cancer patient, for example. It's a real sad situation that if a patient is diagnosed with cancer, first and foremost, for the first 6 weeks, they don't even get any treatment. They have to go through this painstaking process where they get prodded and tests have to be taken, and there's a whole data lineage that's taken, comparing, for example, to the human genome. And the notion of having molecular data and clinical data mashed up together means that you can actually have much, much more of a realistic way to start treating things like cancer in a much shortened period of time. So what in the case of molecular health they're doing is they're looking at the totality of all of the data around us. As patients, clinicians that are producing new research, and of course all of the molecular data that will be associated, maybe it's a cell work, body work that's going on for any single patient, and to be able to mash all that information up, be able to do meaningful analysis is extremely important. In the case of STM, this is the Society Transportation of Montreal, what they're using is precision marketing. Imagine on a commute, you've got the monorail here, or you've got the ability to take the train here. On your journey home, there's lots of different things that you could be, maybe attracted to. But the notion of actually having much more precision-based marketing means that as a consumer, I could see things delivered to me based upon my location, whether it's based upon certain loyalty program things that I'm part of already, and those things could be given to me on my route home. In the case of STM, What they're able to do is, for example, as a citizen, taking the tram home on the way home, and I'm, for example, running low on milk, you could be given a real-time loyalty promotion for milk, stop off on the way, or perhaps go on to into one of these grocery stores, and you'll be given an exact loyalty program opportunity there to be able to acquire new goods at a price that's best for me. So this is where we're combining the notion of marketing to become much more precision-orientated and giving value to the individual consumers. In the case of HSE24, this is a home shopping network. This is a big phenomenon in Europe and, of course, in the Western world. I'm not entirely sure how much it's picked up here. But when you're on home shopping networks, you often don't really know what you're looking for. Maybe you see something and it's interesting, you buy it, you click on the website, for example, and you end up downloading and acquiring that piece of merchandise. In the case of HSE, they do about 15 million consignments a year. And the problem that you end up with is if I buy something off a home shopping network, if I don't like the item, I end up returning it. Well, that causes a lot of disruption to the consumer and, of course, to the supplier. In this particular case, in HSE's case, if they can change the return rate by 1%, that can have a 7-figure return response rate in terms of additional profitability to the company. Because they don't have to go through the whole rigmarole of actually having to change the whole, the life cycle, if you like, of acquiring a good, bringing it back in, paying a stock replenishment charge, and the whole notion that goes with this poor performance, if you like, of the consumer. So in each and every one of these cases, this has been a transformation opportunity using big data. In the case of, once again, of molecular health, this is precision medicine. In the case of STM, this is precision marketing. In the case of HSE, this is the notion of being able to use much more customer intelligence and commerce intelligence and insight to be able to use solutions to be able to get to that level of insight. Now, in each one of these cases, what I described there is an opportunity to be able to use big data. But just to change the story a little bit here, the big problem that we run into in our industry is that really we want to drive towards simplification, but sometimes standards can really help us. And what you see here is a picture here of a standard shipping container. You can see this thing here. This is a standard shipping container. It's perfectly aligned to be able to go on a ship, or on a train, on a ship, or being delivered to the warehouse. It was actually a pioneer, a guy by the name of Malcolm McLean, in 1956, that came up with this concept of a standard shipping container, these boxes. It's about 20 meters by 3 meters in dimension. There's about 17 million of these containers roaming around the world in various locations and various ports. And this guy, Malcolm McLean, is credited with being one of the biggest pioneers that's affected world trade. In fact, there was a study carried out by the American University which recently concluded that because of that standard shipping container, there was an 800% increase in bilateral trade between the various continents, Americas and Europe in particular. And that standardization of that box alone has contributed more than the trade agreements over the last 50 years. So imagine that. This is what standards can achieve for us. And complexity lives in all four corners of our enterprises. You look at this, for example. You have this notion of information that could be scattered, or it could be batch-orientated, which is not really giving the opportunity to realize the value of the information because there's too much latency associated with that information. And of course, we run into the classic technology limitations, too much complexity. In fact, there was a study carried out by the Global Simplicity Index, or Global Simplicity Organization, which measures complexity in 5 dimensions. There's product complexity, there's process complexity, there's people complexity. There's actually, if you have a strategy, a company strategy, there's a complexity associated with that. And then, of course, your entire products and solutions that you provide. Across each one of these vectors, there's an order of magnitude of complexity that comes into each organization. And what this analysis, or this Global Simplicity Index carried out, was that there's a 10.2% loss of profitability, or approximately $237 billion is lost in the most profitable 200 companies a year because they cannot grasp this level of complexity. So with all of this innovation, with all of the big data pursuits that every company has, it comes back down to the basics. You have to be able to deal with the complexity in each one of these organizations. In order to drive forward innovation, what SAP has been focusing on is fundamentally to eliminate that complexity, have a simplification experience for the customer. The second thing is you need to have a set of transformative technologies that allow you to be able to realize the value of the business. And thirdly, you want to be able to extend and have agility to extend very, very easily. So what we have been focusing on is fundamentally a platform for simplification. We call it SAP HANA. I'll give you some color about that in just a minute. And from a transformational point of view, we've been really going back through the whole history of SAP as a company. And we've been focusing on business software for the past 40 years. But we created a lot of complexity in our own right. And it's now our responsibility to really look at the platform and try to simplify it. And recently we announced something called S4, which is a fourth generation of our business software, which really plays to the innovation opportunities of our customers. And the third area that I'm going to really quickly just comment on is having extensibility using more of a platform as a service approach. This is where we can have extensibility, being able to be driven through on-premise to the cloud, or whether it's cloud to cloud, extensibility, but without actually having to incur a lot of extra overhead on-premise. So let's go through these very quickly individually. I'll start off with this SAP HANA platform. If you look at the market today, what the market comprises of is IT, and people within IT are cultured to think that there has to be a certain set of environments to be able to support transactional systems, for example. And then after you've done the transaction, you want to be able to analyze the data, so we have analytical environments. After we've done the analytics, maybe we want to be able to predict the future, so we have predictive environments. And the list goes on. So for each discrete part of IT, we've almost incurred the penalty and the overhead of having all of these different pieces within infrastructure. So transactional OLTP databases, for example, or analytical OLAP repositories, or predictive analytical environments, and also these things go on and on and on. The value add of our platform really is that we're saying all applications to be able to run on an in-memory computing platform called SAP HANA. And this SAP HANA platform is a modern platform which runs tens of thousands of times faster than a traditional disk-based solution, because all of the information is readily available in memory. So you can start analyzing it and also transacting on it simultaneously. The fundamental difference, of course, is that it's a dramatically simplified environment because we've eliminated a lot of that complexity that I talked about. So you don't need to have these separate systems anymore. Think of SAP HANA being a complexity eliminator. It's a deep simplifier. It brings all of these different discrete workloads together under one roof, and we call this an in-memory computing platform, which allows productivity and innovation to be driven intrinsically as a consequence of this platform. And what we're having now is transactional apps and, of course, analytical apps. SAP is redefining all of its own applications, this S4 HANA set of apps, all now running natively on this S4 HANA platform. Of course, partner and ISV applications and custom applications can also coexist on the same platform as well. So we're using this as our big data platform, which truly allows innovation to be achieved. Very quickly, the S4 HANA concept really is to eliminate complexity in the existing business models that we've created over time, where these processes were cast in stone, where we'd have the concept of pre-aggregation, having to have summary result sets, have batch orientation. All of this gets eliminated with the concept of running natively on an in-memory platform like HANA. The other value add, of course, is that business decisions can now be taken in near real time, or real time, to be perfectly honest. Because if you don't have any latency between a transaction occurring and the ability to do analytics on that data, you effectively get rid of a lot of the latency in the environment. So it becomes much more of a business-based, decision-based platform. And finally, in terms of the business processes, we recently took a look at one of the primary requirements of every business, which is running financials. We have this thing called simple finance. And what we've done is we've eliminated the time it takes you to be able to simulate and forecast a month end, a year end, or even a day end close, and being able to do so multiple times within a day. So the benefit of this really is that we've created a platform, a transformational platform, that allows us to be able to revisit and reevaluate the businesses, of course, we're running. In terms of the extensibility, finally here, I'll just comment on this, is that we wanted to have a single platform as a service capability to be able to have not just on-premise customization, which becomes has a penalty to cover over the years. We wanted to have the ability to be able to extend an application to the cloud, have customization in a platform SaaS offering, but then also be able to extend it. So think of the developer requirements in the future. Rather than developing apps on-premise, there will be a platform as a service capability where not only can you extend SAP applications to, you can also build new applications and, of course, integrate even cloud to cloud offerings. So that's where the complexity of these cloud offerings are coming from, is you end up with these silos of SaaS offerings. And with our HANA Cloud platform, we can integrate all of these individual SaaS offerings into one single platform environment again. So the other final point that I want to just comment on is on the Internet of Things. There is a whole host of solutions that SAP has been focusing on, whether it's for connected cars, whether it's for connected logistics, whether it's for connected procurement. All of these become solutions because now we can start ingesting all of this data within a single platform. We can start looking at the data in the variety of information coming off sensors, and we can relay all this information in a single platform, which of course is HANA, and it allows us to be able to look at all of the agnostic value of hardware across the stack to be able to start building these very specific industry solutions. To give one specific example around predictive maintenance, imagine your car today. Each and every time you end up with a fault in the car, more often than not, it's after the event. You then take it to the dealership, and the dealership will sort it out after the event. But with the number of sensors that you now have, there's more than 5 kilometers of cabling in a modern car, more than 60 processing units that you have within every single vehicle, and every single aspect of the car, from the brake pads through to the camshaft, every single piece of information that could be gathered could be used to provide preventative maintenance or predictive maintenance. And this is the solution set that we're focusing on. Now, in order for us to get a real practical value add, it's my pleasure and my delight to be able to call on stage Dr. Gérard Krause, who's going to be able to give some examples around how we can use technology in a meaningful way to be able to fight pandemics like Ebola. And Dr. Krause has done some significant research and analysis in this space. And let's just warmly receive Dr. Krause here. Thank you.
Thank you very much. Can you hear me? Yeah. Thank you very much. I'm now trying to give an example of an emergency that we had in infectious diseases, or we still have, in West Africa. You may have heard about the Ebola outbreak in West Africa. And this is a disease that is fairly recent. The virus was known only in '75. But since then, until very recently, it didn't cause all very big damage. It was caused smaller outbreaks, very severe outbreaks, but confined outbreaks in Central Africa, as you can see here on the, now you can hear me, huh? As you can see me here on the screen. And those outbreaks used to be smaller outbreaks in smaller villages. The villages were not so connected, and they could be contained fairly quickly. So altogether, until very recently, they only caused 2,600 patients. But now, in December 2013, we had this outbreak in West Africa, and it quickly developed to an outbreak that we have never seen before, and I myself was not imagining that Ebola could cause such a big outbreak. So in August 2014, there was an outbreak of this bigger outbreak also in Nigeria. And you know, Nigeria is one of the highest populated and highest interconnected countries in Africa. And we saw when this outbreak is not going to be controlled very quickly, this is going to be a problem for the whole world. So colleagues in Nigeria that called me, and we discussed how we can maybe address the situation. They invested a lot of efforts in controlling this outbreak. And you must know that for Ebola, there's no vaccine available, there's no specific drug available. So we have to go back to the old-fashioned way of infectious disease control, which means every patient has to be isolated, and every person that had contact to such a patient must be followed up and must also be put under quarantine to make sure that no infections will be transmitted from this contact person to additional contact persons. So what does that mean? That means that you have to identify a patient very early on, and as soon as you identify and verify that a patient has this disease, you have to identify all the people that had contact with this patient. And then you have to follow up those people for the incubation period. And in Ebola, that is 21 days. 21 days from the exposure to the disease until you get the disease yourself. So you have to follow up those contact persons for 24 days, make sure that they don't get the disease, and if they should get the disease, that they will be treated and separated and isolated immediately. So I think that it's difficult to hear me, I think. Huh? Is it okay? So you can easily imagine what this means if at the beginning of an outbreak, of an epidemic, it can quickly go up because all the many contacts that people may have. If you have a situation like in a church or like in a mosque or in another football game or so, quickly you have many, many, many contacts to one single case. And it's very difficult to identify and follow up all those contacts. So this is where we basically try to develop a solution, because the Nigerian colleagues worked very hard, but they had also very beneficial situations. This one patient that came into Nigeria was known beforehand to have the disease. And he only had a fairly small number of contacts. So it was possible with a lot of efforts to really control this outbreak early on. But the Nigerian colleagues themselves told me, if we had had a situation like in Sierra Leone, where people were coming in through the inland, or many people coming in at once, or maybe people hiding at first, or maybe people not going to the hospital right away, then we would not have been able to control such an outbreak. So what do we do? So the question was, we need to have a comprehensive system that will at the same time address the identification of cases of new patients, but also the verification of the diagnosis, because at the beginning the symptoms are very common, like fever or so. You don't know right away that it's going to be this severe disease. So you need to have a triage, you need to have a diagnosis, you need to verify the cases, which is fairly complex. And once you have identified the case, you need to, as I said, follow up all the persons that had contacts, family members, working colleagues, and so on. And so this is fairly complex because, like in Nigeria, this one initial case 0 caused almost 900 contacts. And they had to be followed up for 21 days. So you imagine what this means. One healthcare worker having to go to each of those contact persons every day measuring temperature. So at the same point, this also means that the system needs to be bidirectional, that information does not only have to go from the periphery to the center to be analyzed somewhere, but also from the center immediately information needs to go back to the periphery, to the local healthcare worker, to give him instructions what to do next, to be most efficient. Maybe a contact moves from one area to the next so that the other healthcare worker can take care of him. And then the whole thing needs to be integrated into systems that are already in place. So we took good care to not build another silo completely independent from existing information systems, but to integrate all those into the existing surveillance system and healthcare and maintenance systems, which was also not so easy. And then another objective was to have the whole thing field compatible. That means in West Africa, oftentimes you have large areas that don't have electricity all the day. Maybe for many days they don't have electricity. They don't have the internet. But ironically, most of the times the mobile phone does work. So as long as you can get a generator to charge your cell phone every once in a while, you do have connectivity. And this is where we use this situation to build our system based on cell phones. And to then at the same time be independent from electricity and the internet. And the other very important point that, of course, I must stress, being a scientist myself, that the whole content and the relationships and the process models of all this need to be scientifically sound, fitting to the disease that we are going to control. So this is what we came up with, and we built this system by identifying first who are going to be the users of such a system. So the field officers, the scientists, the physicians, the lab workers, and we all interviewed them, we included them into the process of developing this process model. And those are the different personas, we call them. Those are the persons that are involved in the different processes. So from the healthcare facility, information comes in to the informant. They do the first triage and send it on to the surveillance officer. Also, rumors may come in through a hotline, and there it's going to be triaged by the rumor officer and then forwarded to the surveillance supervisor. And he then decides whether to further follow up on this and to do further investigations. And if that case turns out to be a case by laboratory confirmation, then all the management, isolation, and treatment is being done. And then also the contact persons needed to be followed up every day, fever being measured every day on site, and make sure that the quarantine is being maintained. So this is a simplified process model, of course. In reality, it becomes fairly complex. But it shows you that many, many players are involved. They are distributed all over the area in very rural situations, and they are connected to the central hubs on the national and international level. So this is basically what we displayed, and we use the mobile phone applications for the mobile officers in the field to enter the data, but also to receive information back. As today, actually, Monday, we are starting our pilot in Nigeria, in 2 states in Nigeria. And if that pilot will work well for the next 5 weeks, and if it proves to really solve the solution and solve the challenges, then we could basically get one step further to having kind of a standard system for disease surveillance and outbreak outbreak response in Africa, but maybe also in other countries. We just presented the system to the WHO, to the World Health Organization, last Friday, and they immediately asked us whether we would be able to adapt the system to the MERS coronavirus, which in this area is of further interest. And you have recently heard that also new cases have been identified in Korea. So, of course, we can adapt it. It needs to be done again in a proper way, following the natural items and the specific needs of this disease, but there's no reason it couldn't be adapted to other diseases. So this is what we are currently working on. It's one of the applications to use modern technology, I guess, for disease control. Thank you very much.
So that was a fantastic summarization of how data and big data can be used in a very efficient and meaningful way to help prevent and cure these malicious diseases, okay, right, that if not managed effectively could spread widely. So, I mean, I'm in awe of, you know, Professor Krause and the work that he does and the team that, of course, he's part of that does this kind of groundbreaking research. But if we look at the technology foundations just that underpin that type of solution, it's worthwhile pointing out that if you look at the stack, we essentially have the platform around SAP HANA and the mobile platform that actually entitles and enables all of these different personas to be used within the field in a meaningful way to capture the information and then allow that information to be processed. On top of that, we have this predictive analytics capability within our platform. So imagine when you have that customer or patient 0 that potentially is the source of spreading the virus. It's important for us to be able to build a graph of all of the potential interactions and those interactions that have further interactions so that we can very quickly be able to build an infographic, being able to give that information to a caseworker so they can very quickly start to be able to navigate around the various townships or the cities or, for example, the villages to be able to identify these patients. On top of that, we also have the ability to use the visualization technology called SAP Lumira, and on top of which, we're also now extending this trial, and potentially what we'll be able to do is, using the concept of what we call the business network, all of the provisioning of all the various types of information that we have can now be rendered in a way where we can actually start doing procurement directly from that information as well. So the notion of having a business network is just like we have networks like eBay that allow us as consumers to be able to go and acquire things, or Alibaba. The value of a business network and the notion of being able to combine suppliers and, of course, consumers within a first-class business network allows SAP to be able to not only drive analytics, but then also be able to use our business network to be able to start doing procurement. So imagine there was some medical provisions that we needed to go and acquire, some resources that were required. The mobile application can initiate a process flow that will actually initiate the request to go and acquire a piece of merchandise directly from a supplier as well. So that's linking the business network. And then right on top, we have, of course, our mobile cloud platform, SAP HANA Cloud Platform, that allows us to be able to host this application. So all of the application logic that was described by Professor Krause is actually hosted in our HANA Cloud Platform environment. So that's the venue of interaction, the venue of communication for these field workers. So in conclusion, as I ask and leave you in this forum here, I will ask you to do 3 things. The first thing is I would ask you and urge you to take a look at the complexity of environments. There's a simplification roadmap that you can create for yourselves. And the notion of having a platform like HANA, which integrates with Hadoop, which integrates with traditional platforms, that allows all of these different contingent pieces to come together, will truly allow you to simplify and innovate. The second part is in transformation. SAP is radically changing all of its applications along the lines of this S/4HANA, which is now not just using our platform just as a system of record, but using it as a system of innovation. So these new applications are truly being driven by new value adds, new extensions. And that extension can be built into the extension platform of SAP, which is our HANA Cloud Platform. So think of it this way: simplify your environment, look to transform your value to become much more innovative, and then extend what you have to a cloud platform that is conducive to being able to do all this innovation. So I'd like to thank you for your attention today. I hope you have a valuable 2 days, and I hope that the sessions that you have ahead of you will give you the insight that you desire. Thank you very much.